Hi, everybody. And I'm Riivo Talviste. I'm going to give you an overview of how we are integrating our Sharemind MPC framework into Carbyne Stack. And don't worry, I will explain what Carbyne Stack is also. Quick outline. First, I'm going to introduce what's Sharemind MPC, then how we think about like separating MPC runtime and platform, and finally our integration plans with Carbyne Stack. So here you go. This is Sharemind MPC. For this audience, I think it's relevant that we are, because you can do MPC in different ways, it's relevant probably that we use additive secret sharing. We have free computation nodes, and our most evolved like MPC suite uses passive security. So in the middle there, you have like this is like one of the many deployments we have had. In the middle there, you have those free computation nodes in this particular case. And on the left side, you have data owners or input parties. In this case, there are two. So they basically secret share their data, distribute the shares among the free computation nodes, and then they can leave. So they are no longer needed. So they just upload their shares and that's it. And in Sharemind MPC, there is no restriction on the number of input parties. So then there can be even thousands of those. And then the data flow goes to the right side where there is this output party or result party that actually invokes the actual MPC program that does something that is previously agreed upon and also gets the output shares to reconstruct the result value. So that's a simplified overview of Sharemind MPC. So here are some of our like selected deployments over the years. As you can see, we have been in the game for quite some time. So our first practical deployment with real data was in 2011. And the novelty there was that it was, to the best of our knowledge, the first time MPC was running over the internet. Then the other deployment I would like to point out is from 2015. So this is actually what this picture was about. So there was, so it's interesting because it's the largest in sense of data volume for us. So we got over 10 million tax records from the Tax and Customs Board. And also second important thing was that the actual analysis was not done by us or any cryptographer, but actually a professional statistician using a tool called RMind, which is basically your statistical analysis tool R, but built on MPC. And finally, I'd like to point out one of the most recent deployments from the end of last year, where two hospitals, namely Ludwig Maximilian University Hospital in Munich and Gemelli Hospital in Rome, collaboratively analyzed their tumor treatment radiotherapy data sets. So the results are yet to be published. The paper is being written. But why this is novel or important for us is that it was the type of project where we didn't do anything. Basically, the customer bought this license from us to get Sharemind MPC and then handle everything else on their own. So from getting ethics committee approval to writing TPIAs and talking to the local TPA, and also writing Carbyne scripts and doing all of the communication. So that was pretty cool. Anyway, and all of those deployments except the first one were done using Sharemind application server that we have developed for 13 years now. So in the middle of it are the MPC protocols themselves, and we call those protection domains. So what is a protection domain is basically you can have different types of MPC protocol collections or suites. So for example, one is shared free P, which means that it uses additive secret sharing, free parties, and passive security. So that was the one I was talking about previously. But we also have one with 2 parties and active security, and also one with 3 parties and active security is under construction. So you can basically switch out the underlying MPC engine there. And then the rest is basically, programs for Sharemind application server are written in a special language called secrecy. What secrecy gives you is it basically separates private and public data flow, so you can't really easily accidentally leak private data, because it knows that secret shared data is secret shared and it has to be handled by MPC protocols, so you can't accidentally leak it. You have to explicitly make it public if you want to. And the rest of the boxes are actually supporting elements. For example, there's if you need to do pre-computation for actively secure protection domain, then you need pre-computation. Then you need storage. We have 2 storage modules. One is key value based, backed by Redis server, and the other one is tabular one, because most of actually data analytics, workflows want basically CSV data. And then there is, of course, access control implemented by authentication and authorization, and so on. And on the bottom, there are different ways how you can interface with Sharemind application server. So you can use one of their ready-made applications. I mentioned Rmind already. Then CSV importer is something that is mostly used by data owners. So it takes a CSV, secret shares everything, and uploads it to the servers. You can write your own application in C++, Haskell, or Java. Or if you want to do web-based data input or output, then you can use JavaScript client library. So that's Sharemind application server for you. So why we like it is that, well, it works. So each feature complete, and it has proven itself useful for many different scenarios, from service to huge data analysis projects. So it basically has everything. It's also modular, meaning that you can plug in new protection domains if there's advancement in this research, for example. And since we have been developing it for 13 years, then we of course have a bunch of tools that already work with it, and processes that work with it, because again, it's really modular. However, on the other side, the fact that it actually does everything and contains everything is also a disadvantage, because, well, we want to do MPC, but we also, in order to get everything working and deploying, we have to do session management for users. We have to do task management, because you can run many secrecy programs in parallel, and we have to do networking. But what we would like to do is actually concentrate on our strengths. So we would like to develop new protection domains, so do crypto and MPC, like the actual core MPC. We have the secrecy language that is open source, by the way, and it's quite extensive standard library. So we want to put emphasis on that. And we really like our data analytics capabilities, also containing Rmind. So yeah, we would like to do these things, not like supporting stuff so much. Also, the fact that it's actually like it's been developed so long is very possible for some features to creep in there. For example, at the moment, it supports multiple protection domains in parallel. So you can have one single secrecy program that supports a protection domain that uses 3 parties and 2 parties. And you can actually like even reshare things from 3 parties to 2 parties and vice versa. Nobody has ever used it in production, but it's there. And lastly, time has gone by, and actually the computation parties or the hosts are expecting different deployment mechanisms now. For example, a lot of them have local Kubernetes clusters, or they want to deploy this thing in a public cloud, and they are expecting like containers and images and stuff like that, and also scalability. So we need to get friendly with cloud. So we took a step back and tried to think about divide this thing into basically like components and what's the meaning of each part. And we at the moment have come up with this separation of runtime and platform. It's probably nothing new, but it took some effort to actually convince ourselves about this. So MPC runtime can be something really minimal. So it just takes your MPC code in whatever language it's written in basically, and then contains MPC protocols that are able to basically run this code or do the MPC stuff. And then in order to do MPC, you of course need some basic method to exchange messages, which means you need some point-to-point communication probably. And that's runtime. And then comes the platform, and this can be more involved. So it, for example, provides methods for interfacing with different client applications, together, of course, with authentication and authorization. Also, all kinds of supporting facilities like storage, pre-computation, different policies, so on. And it would be nice if it also has discovery, coordination, orchestration, and so on. So if we now divide it into 2 like this, then we'll get to Carbyne Stack. So if you haven't yet heard about Carbyne Stack, if you don't know what it is, it's an open source MPC platform on Kubernetes. It's developed mainly by Bosch research at the moment, and helped out with a few contributors. It uses a microservices architecture and cloud native design principles. So the different, on the picture here, you see a deployment with 2 VCPs or basically computation parties. And the different microservices are, for example, ephemeral is thing that actually invokes the MPC engine or runtime or the computation, and Amphora deals with storage of signatures. Yep. How we would why we like Carbyne Stack is that we can concentrate on the things that we love as cryptographers, and we can leave the error-prone distributed system stuff to distributed systems people, because Carbyne Stack, at least initially, was developed by distributed systems people. So let them do the task management, the session management, and supporting stuff. And as a result, we get this, because it's built on Kubernetes and cloud-native technologies, we get this cloud compatibility basically for free. For example, elasticity, scalability, and also we get with working with them we get these like nice, let's say, best practices that are used nowadays. For example, infrastructure as code and different types of automation. From our side, what we hope to contribute is practical working machine optimized MPC protocols, first of all, like the runtime, then secrecy language with its ecosystem, and also hopefully some experience, because we think that we have some knowledge on how to deploy MPC for real world solutions. So how we are going to do that? First, we'll take this task as a process approach, which means basically that the MPC runtime is packaged as a self-contained executable that just runs a single task and then exits. So it just finds its, in our case, 2 friends on the network, does its computation, which means basically runs a single secrecy program and then exits. And all of the supporting facilities are then provided by the platform, in this case meaning Carbyne Stack. So currently Carbyne Stack has a single MPC like backend or engine or runtime, however you would like to call it. It's MP Speeds, open source project. And MPC follows this model, and we will package Sharemind MPC similarly, so it just runs one task and exits. So it can be like an alternative to the open source MP Speeds. By doing that, we lose like basically all of the functionality that we have built over the years, like all this like tabular storage, authentication, authorization, everything. So we'll add this little by little, like mainly to the platform level, collaborating with push research, and also something to the runtime. So first, we'll basically lose everything. Yep, and this is where we are at the moment. So we started quite some time ago, exactly with this picture. So just throwing away everything from the Sharemind application server, just leaving the core, the MPC protocols. We have implemented this, it works. So just recently, we finished another milestone, which was adding input and output for those MPC tasks, which gives you the ability to add runtime arguments, either secret shared or public runtime arguments to your program, and then also get the published result back or the computation result back with one of the client tools or like the client-side applications. Currently, we are working on and actually finishing the re-implementing the tabular database on Carbyne Stack because, well, our tools really need it. We love tabular databases more than key value databases, or at least have used them more. One of the next big things would be to add transaction support on the task level, and task in our case is just like a single secrecy program. What that means is that, for example, it's a distributed system, errors can happen. So what if at any point in time, network breaks down or whatever, so transaction gives you that at least the persistent storage is consistent and coherent over all of the computation nodes. So you can just, for example, restart the computation and hope it goes through. So transaction support is really important. And of course, in parallel to all of this, we work with Bosch Research, Carbyne Stack owners, to upstream our changes to the Carbyne Stack platform and also open source relevant parts in our work. So one of the first things is that Carbyne Stack will be able to handle different MPC backends or runtimes. So in addition to MPC, it's also Sharemind MPC, and there can be others if you want to add your frameworks there. And yeah, we'll also open source our tabular table storage interface. And with that, I'd like to conclude. And if you like to see this in action, or the current version, the application server in action, then come see us at the industry session on Wednesday. Thanks.